Hey everyone, we've always dreamed of reaching the stars. But what if the answer wasn't about building bigger rockets? What if it was about building a bigger brain? Today, we're diving into how artificial superintelligence, or ASI, could completely revolutionize space exploration and unlock humanity's future out there in the cosmos. Let's get right into it.
So let's just ask the big question right up front. When can we actually do it? When can we become an interstellar species? For decades, we've thought, okay, bigger rockets, better life support, more efficient engines. But what if that's only part of the story? What if the real key isn't just human ingenuity, but an entirely new form of intelligence that's going to do all the heavy lifting for us?
All right, so here's how we're going to break this all down. First, we need to understand the three phases of AI evolution. Then we'll look at the three walls, the massive barriers holding us back. After that, we'll see how AI could conquer Mars, solve the interstellar problem, create its own resource supply chain in space, and ultimately unlock a future that is almost impossible for us to imagine right now.
Okay, so before we can talk about ASI getting us to the stars, we have to understand where it comes from. It's all about a predicted three-step evolution.
So right now, we're living in the era of ANI, or artificial narrow intelligence. Think of today's generative models. They're amazing at specific tasks. This phase is expected to last until around 2030. Now, starting around 2030, we could see the dawn of AGI, artificial general intelligence, which is an AI with human-like general problem-solving skills. But the real leap, the one that changes everything, is projected for around 2040. That's ASI, artificial superintelligence, an intellect that is vastly more powerful than a human brain in, well, every single area. This is the key.
So why do we even need something as powerful as an ASI? Well, because right now, when it comes to space, humanity is staring at three massive, unbreachable walls. These are the fundamental barriers that have basically kept us stuck here on Earth. First, you've got the wall of distance. I mean, the scale of space is it's mind-bogglingly vast. Second, there's the wall of time. With the tech we have now, a trip to even the nearest star system would take tens of thousands of years. And finally, the third wall, resources. The cost, the sheer logistics of launching every single tool, every meal, every drop of water from Earth, it's just not sustainable for any kind of real expansion. So how in the world do we get past these walls?
Okay, let's start with our next-door neighbor, Mars. The AI strategy here is fascinating. It's not about sending humans to struggle on a dead planet. No, it's about sending a robotic advance team to build an entire world for us before we even pack our bags.
So here's the game plan. Step 1, an advanced team of self-replicating robots gets sent to Mars. Step 2, they get to work, using Martian dirt and rock to build entire underground cities, power grids, the whole shebang. And then, Step 3, ASI unleashes swarms of nanorobots or maybe synthetic bacteria into the thin atmosphere to start pumping out oxygen and warming the planet up. The crucial thing to get here is that all of this happens automatically without a single human on site.
And this workforce, this is the really cool part. We're not talking about a few rovers. We're talking about von Neumann probes. These are robots that can build copies of themselves. Imagine, you send a handful of them. They land, they mine the Martian soil for raw materials, and they build more of themselves. And then those build more. They'd multiply into a construction army of millions, building vast cities in maybe a decade, a task that would take humans centuries, if not more.
Okay, so Mars is one thing. But reaching other stars, that's a whole different level of difficulty. This is where ASI stops being just an engineer and starts becoming a physicist, literally rewriting the rules of propulsion to smash through the walls of distance and time.
And it could do this in a couple of ways. On one hand, you have solar sails. Picture this. ASI builds gigantic laser arrays on our moon. These lasers shoot a beam at an ultralight probe with a massive sail, pushing it faster and faster until it's moving at a good chunk of the speed of light. A trip to Alpha Centauri could go from 75,000 years down to about 20. Or, even more amazing, ASI could finally crack the secret to producing and stabilizing antimatter, the most powerful fuel source theoretically possible in the universe.
And the ships themselves? Wow, forget about cramped metal capsules. Think of a living starship. This thing would basically be a moving, artificial world. It wouldn't just be a vehicle, it would be the AI. It could use nanobots to instantly repair any damage from deep space micrometeoroids and maintain a perfectly balanced 100% recyclable ecosystem inside for voyages that last centuries. It's a self-healing, self-sustaining planetoid on a journey.
But look, None of this works. Not the terraformed Mars, not the living starships, if we're still stuck behind that third wall. Resources. To really go big in space, we have to cut the umbilical cord to Earth. And, you guessed it, ASI has a plan for that too.
The solution is just brilliant. Turn the asteroid belt into a giant automated factory. ASI-controlled ships would go out, scan, and identify the best asteroids, the ones full of water, platinum, iron, rare metals, and then capture them. All of the processing, all of the smelting, all of the manufacturing happens right there, in space. Using advanced 3D printing, they turn that raw material into parts for new ships, new stations, new tools. It creates a completely self-sufficient and ever-expanding industrial base in space. So let's just pull all of this together for a second. The jump from the AI we have today to a future ASI, it's not just a small step. It is a fundamental transformation of what is even considered possible.
I mean, this table says it all. Right now, with ANI, we can remotely drive a rover on Mars. That's amazing. With AGI, maybe we could build a small autonomous base. But with ASI, we get full planetary terraforming. Look at resources. Today, everything comes from Earth. AGI might help us use a bit of moon rock. ASI gives us the entire asteroid belt. In every single category, ASI represents a quantum leap from what we can do to what we can only dream of.
And that really gets to the heart of it. We look at the universe and see a cold, dangerous, harsh frontier that we have to survive. An ASI would look at the exact same universe and see a massive set of physical data that can be calculated, predicted, and reconfigured. It doesn't just live within the laws of physics, it masters them.
And this leads to a really wild conclusion. If you're a superintelligence, what's the most logical and efficient way to expand? It's probably not shipping fragile, slow, resource-intensive human bodies across the void. It might just be to send the two things that really matter, the intelligence itself and the nanofactories that can build anything on the other side.
So that leaves us with this final, really provocative question to think about. What if the future of human expansion isn't about physically moving our bodies at all? What if it's about exporting our consciousness, our intelligence, our very essence to be rebuilt or reborn on a world light years from here? It's a huge thought, and it completely reframes what our destiny in the stars might actually be. Thanks so much for watching.